point, what I will write is list of formulae, the different formulas for solving numericals. So velocity potential function will be represented by a symbol that is phi. The stream function will be represented by a symbol psi. Okay. Then by definition, the partial derivative of velocity potential function with respect to any one direction is equal to velocity in that particular direction. Here I have taken the direction x, so velocity in x direction is u, and it is a negative derivative. This is the one formula. Similarly, for y direction, the negative derivative of velocity potential function with respect to y direction is equal to the velocity component in y direction is v. And similarly, the negative derivative of velocity potential function with respect to z direction is velocity component in z direction, that is omega. So this is three formulas. The next is formulas for stream functions. Stream function is represented by symbol psi. Then what is the definite formulas for stream function is the derivative of stream function with respect to any direction, which gives the velocity component perpendicular to this direction here. Perpendicular to this direction, x is direction I have considered. Perpendicular to x direction is perpendicular to x is y. So velocity component in y direction is, that is v. So v is here with negative sign. Okay, and similarly, one more formula, partial derivative of stream function with respect to y direction is equal to, here I would consider the direction y. So y is here, that is perpendicular to y axis is x axis. The velocity component in x axis is, that is equal to u. So u is the formula. And there is no formula or equation or partial derivative equation for stream function along z axis, because it is a two-dimensional flow only. So only x and y, there is no z axis is considered. So these are from formulas. One more formula I will write, the Laplace equation. The Laplace equation for stream function, for example, for velocity potential function, first we will write the Laplace equation for velocity potential function phi is equal to dou square phi upon dou x square plus dou square phi upon dou y square is equal to 0. So what is the significance or purpose of this Laplace equation is, in the question paper you will be given the value of phi. It is not a value, means it is not a definite number, it is a function of some x, y, some equation. So you need to calculate the derivative of phi with respect to x as well as derivative of phi with respect to y. Substitute in this equation. So if you got equal to 0, then it is a case of fluid flow. Case of fluid flow. For 4 marks or 5 marks it will be asked. Or if it is not equal to 0, then it is not a case of fluid flow. Okay. Similarly, the Laplace equation for Laplace equation for stream function psi is equal to dou square phi, not phi here, psi divided by dou x square plus dou square psi divided by dou y square is equal to 0. Again the same fundamental concept you apply here. So if the function psi, if it after deriving derivative of both x and y direction, if it is equal to 0, then it is a possible case of fluid flow. Possible case of fluid flow. Dear friends, here I have considered only two direction here. Here is also considered two direction. Here is also only two-dimensional flow. But in advanced courses, you may ask for three direction also. So one more term will be added in the Laplace equation. Here there will be plus dou square phi upon dou z square will be added. Depends upon the type of function he has given in the question paper. But for Laplace equation for stream function, it is only two-dimensional. It is not three-dimensional flow. So these are the some functions, formulas required for solving the numericals on velocity potential function and stream function. So we'll